So now that we've got our enemies feeling a little bit more fun to destroy, we're going to take a look at making some improvements to the camera to make it feel a little bit more active within the world. So at the moment, I'm just going to maximize this here, we can see the camera is just directly following our player. He's pretty much just staying in the exact middle of the screen the whole time, which is perfectly fine. It works for a lot of different situations, but it can also feel a bit dry, a bit inactive. So what we're going to do is add a lerp to the camera, which makes the camera drag a little bit behind where the player is, but actually makes it a little bit more feeling alive, a little bit sense of a weight to the camera moving around within the world. So it's very, very simple and very straightforward to actually add the lerp to the camera. All we have to do is go into our camera controller script in MonoDevelop that we already have open. So all the camera controller script at the moment is doing is basically replicating if it was a child of the player. It's just actively following exactly the same position of the player. So what we're going to do instead of just following the player, we're just going to comment that out. What we're going to do is say our transform dot position of the camera should be equal to instead of saying a new vector tree, what we're going to say is just vector tree dot lerp. So the lerp function, basically it moves, it'll move between one vector and another over a certain space of time. So what we do is we go from, we have vector tree A and vector tree B here. So A being where we start and B being where we want to go to. So where we're starting is obviously where the camera currently is. So we'll use our transform dot position. So that's where the camera is at the moment. We want to move it to where the player is, or where the player is in relation to the camera, kind of. So yeah, we want to move it to where the player is, basically, which is our target transform here. So we want to say a new vector tree, because we only want to move towards where the player is on the X and Y axis. If we move towards them on the Z axis, we'll actually end up going onto the same position within the world as the player, and then the camera won't be able to see anything. Everything in the world will just disappear. So if you do encounter that bug when you're making your own game and the whole world disappears, check that your Z value of your camera isn't the same as what the Z value of the player is. So our X value will be our target dot position dot X, and our Y value will be target dot position dot Y. And then our Z value, like we said, we want that to remain where the camera is, so that'll just be transform dot position dot Z. So we'll hit no, we don't want to hit semicolon there because we're only at the second part of our lerp. So we have a position we start at, then we have the position we want to go to, then we hit a colon, or not colon, a comma, and we then have a float t. So our t here is the time how long or how much movement basically our lerp is allowed to have, or how quickly it will move from one position to the other. So what we want to do is create a new value up here just below our target, create a new public float that we'll call our camera speed, and then what we want to do here is, so we're lerping the camera, we want to say the speed we want the camera to move at is the camera speed we just created, and we want to multiply that by time dot delta time. Because we're working within our update loop, that will never be a fixed value, so we need to make sure we use time dot delta time so it reflects how much movement the camera should have, or else if we have inconsistent frame rates, our camera will be jumping all over the place, and that's certainly not something we want. Okay, so we'll jump back into the game, let that compile, and we'll jump over to our camera, and we want to give our camera lerp a value. Let's just set it to say 5 by default. If we hit play, see the camera will now follow a little bit behind the player, and when we stop moving the camera will catch up, and it makes the camera, like I said, it makes it feel that a little bit more alive. I'm just going to maximize this here, and you can see the camera follows smoothly along with the player as we drop down, we kill all our enemies still, just the way we want to, exploding, and just, as I said, it makes the camera feel that little bit more active. The same when we jump up and down, the camera doesn't just follow the player, if we put the mouse over where the player is, I'm not going to move the mouse, but you can see the player moves around a lot in the screen, and it makes it feel just a little bit more active.